Is any representative from U.S. Oil here today? Okay, Brian Nudelbacher didn't make it. I just wanted to also say that they just opened up a station in Menominee that Anderson Windows and Dart Transportation went together with the local Cenex cooperative there. So just to give them, that's an update in the market, just to kind of give them kudos for taking the leadership there as well. Let's take a look at a survey that we had commissioned here, and you'll have to pardon my discombobulation. Normally I've got somebody up here running all of this smart stuff, but I got to try to figure out how to run the camera and get it to the right place and do all of that, because I've had quite a few requests for people to view this online later. So this is something that we sent out to many different fleets just to kind of get a flavor of what the market was, and here are the results. My company is exploring ways to maintain or lower fuel costs for our fleet vehicles, and you see that the yes is overwhelming, and obviously that has a lot of people's attention. This is not a huge market survey, but it's big enough to an indicator of what's going on. I expect the fuel prices to rise or keep going up or remain steady. Obviously, we all think it's not going to just stay where it's at or go down. That's the same chart, just done in a different way. I apologize. I didn't do this PowerPoint myself. My survey guy did. 84% of people are interested in a commercial fuel source that isn't subject to global markets or weather or those kinds of things. Although weather can play a factor, at the WPS meeting this morning they were talking about hurricanes having been a reason for the spike in, what was it, 2004 or 2005 as far as cost goes. So you're never going to get a fuel that's totally non-weather dependent, but at least you can get something that isn't dependent upon foreign negotiations. 84% of people that were familiar with alternative fuels, including compressed natural gas. And 45% of people said that it's a viable alternative, 42% weren't sure, and 13% said no. So again, the overwhelming majority, if you factor in the 45 and the 42, believe that this has some potential. As far as it being a safe fuel, 42% agreed, 32% strongly agreed, 10% really didn't agree or disagree, and 10% didn't know. So just to go on the record, it is a very safe fuel. Is it an economical alternative to gasoline or diesel? Again, you see the agree and strongly agree are very high percentages. And the fuel economy is something that we're often asked, is it worse or better? 42% believe that it's the same as traditional fuels. Again, that depends a little bit on your vehicle and how it's converted and a lot of different factors, but the short answer is when you're talking BTU to BTU, you're not taking a big hit on mileage. And a very small percentage said that it would be worse or better than traditional fuels for economy. What factors would need to be in place for your company to invest in CNG modifications for its fleet? You'd have to have enough filling stations. 25% of people said that would be an issue. Certified shops to modify vehicles within a reasonable distance. 17% are, wait a minute, this is actually not percentages because they don't add up to 100. This is people who responded to the survey, and tax or other financial incentives available. This is how far you would travel to modify a CNG vehicle. Again, you can read the chart as well as I can there. Most people want it to be relatively local. And the majority of miles that, again, the survey results that we got are a combination of rural and urban. Again, just kind of a throw in there slide. And the maximum distance a company would travel to purchase CNG fuel, and this is pretty telling, a vast majority, 60-some%, say they want a local close fueling station, and that certainly would be at least within 30 miles, and that's the lion's share of it. And then this is obviously a really straightforward question. Saving 40 to 60% or more in fuel costs is of interest to my company. Nobody said they strongly disagree with that. No, we wouldn't want to save money. When did you last hear that? And how many vehicles are there in the fleet? These were kind of a cross-section. 19% had more than 50 vehicles that responded to the survey. You can see the chart there. And again, this is kind of the makeup of vehicles that the respondents to the survey put in. So we've got really a wide variety of heavy-duty, light-duty, and the entire scenario. And this is the total miles driven per year for all vehicles. Again, you can read the chart, and I can make this available to you. I may actually have it posted online, I'm not sure, but that's the end of my slide. And Corey, go ahead.
You can see we're a well-rehearsed and professional organization. Next up, we're going to welcome Lee Otto from CNG Paul. Oh, there's it again. Oh. Sorry, Lee. Lee, come tell us all about all the good things about CNG and stuff. Welcome, Corey. These are pretty stingy kids. Come on, boys, let's go.
Am I all plugged in and ready to go?
Yeah, it should be.
There, I guess I'm all wired up. Well, good afternoon. It's really awesome to be here, figuring how just a short 3 years ago, Bob and I met at the Renewable Energy Show down in Custard, and we started talking about CNG and compressed natural gas, and Bob has taken the bull by the horns. All of you are here. This is really exciting to see how fast this entire industry has changed. I'm Lee Otto with a CNG pump. Our company is Energy Hybrids. And am I up?
You are. Yeah, you are not up because I'm messing with this thing and I'll figure it out.
Let me know when you're ready to go and I'll get started with this.
I apologize. Do I look like an IT?
There you go. And speaking of IT, I had a bunch of really neat video presentations about some CNG conversions and my participation in the World Race 2011 promoting alternative fuels, but that technology isn't working today either. Here's the video. We'll skip that. The World Race 2011 was to commemorate the Great World Race of 1908. Back in 1908, there were about a dozen very adventurous men from around the world that set out from New York to San Francisco. Their cars all got put on a ship to Beijing, China, and then a total of 24,000 miles from New York all the way across the ocean, all the way to Paris. That race back in 1908 was won by the American driver Thomas Schuster, driving the American Flyer car. 100 years later, we decided to retrace that route and redo that race last year in 2011. We actually had the great-grandson of Thomas Schuster that recorded, and I had a bunch of videos on here, and recorded the race. But back in 1908, the reason the race was done was to promote a form of transportation called the automobile, to prove it was safe and it was reliable. In 2011, we did the race with a little different twist. Our purpose was to prove to the world that alternative fuels were safe. This is the actual car, the Thomas Flyer, it's in Reno, Nevada, at the museum, that won the race back in 1908. This last year, this is the car that won the race. It's a 2007 Corvette, which was purposely bought to commemorate the 1907 Thomas Flyer. This car was really cool. This car ran on 7 different fuels. it ran on gasoline, it ran on E85, it ran on CNG, LP, and for a stretch across Russia, it ran a full tank of vodka. They gave us 300 gallons. I wasn't there, but they gave them 300 gallons of vodka, and they ran one tank, and they had no way, they couldn't figure out how to haul this 300 gallons around in the shuttle vehicles that followed. But so anyway, we proved it. It did run. But it was fascinating because Jerry Price, the owner of this car and the organizer of the race with Price Team Racing, his entire concept is I don't want to be locked into any one fuel. I want to be locked into the most practical fuel for the area and the most cost viable fuel. I want options. So that was really neat. This was my car. This is car number 5 in the world race. We had a little different strategy. We went from Wisconsin, from New York to San Francisco, and from San Francisco back to Wisconsin with the intent of setting a national record for the longest distance traveled on natural gas. Well, we didn't do it. We, with all best intentions, with navigators back home trying to reroute us to get to the CNG stations, we proved that this country's infrastructure was very, very weak on CNG. And if anybody wants to know the most strategic interstate locations to put CNG stations and make some money, talk to me, I'll guide you. I know every spot in this country that we need them. We even double tanked that car, which nobody's supposed to really know about, but we double tanked the whole trunk was CNG tanks. Today we're going to cover CNG conversions. We're going to cover gas conversions, sequential. We're going to go over the different types of sequential, upgrade, and aspirated systems. Very few people know about car applications with turbo. We're going to go over diesel conversions, primarily booster systems on diesels, EPA versus non-EPA conversion kits, which is the controversial thing Bob was referring to earlier. And if any of the videos work, we might get some highlights of the World Race 2011. This was an actual picture that I took on the race. Look at the fuel prices, look at natural gas, and look at where propane was, public fueling stations. My car, that's a sticker on the back of my car, it says, I go both ways, natural gas or gasoline. And I had to laugh because I have these huge CNG pump stickers on the side of my car, but I can't understand why that's the one everybody notices. I don't get it. Typically, when we set up a CNG car, we try to set it up so it gets about a 200-mile range on fuel. You can use CNG in both gasoline and diesel vehicles. A little computer chip does it all, or you can refuel at home. Now, thanks to guys like Bob, there's a lot. And Quick Trip and US Oil, there's a lot of progressive activity going on in the state, so this is definitely the time, if you're considering to switch to CNG, now is the time to do it. You can convert cars, you can convert school buses, vans, just about any gasoline or diesel vehicle can be converted to run on natural gas. Now, the neat thing about the wholesale price, if you do have your own small filling station, is the wholesale price on natural gas is under 75 cents a gallon in most of the areas of the state. Now let's talk about terminology. I have a lot of material, so I'm going to move really fast. If you have questions, make a note. I'll be happy to take the time later to ask. Sequential injection system, an upgrade kit, something new, nobody even knows about that yet. Aspirated systems that use vacuum, and then how fumigation works or direct injection works. Now, terms you need to know in a sequential injection system. In a gas vehicle, you're going to have the tank, the regulator, injectors, stainless line, compression fittings, a gauge, NGV nozzle, fittings and connectors, ECU and cables, low pressure hose, a fuel gauge, electronic shutoff. You're going to have to drill the intake manifold and then computer term the system. Tanks come in type 1, 2, 3, and 4 tanks. The next speaker is going to cover a little more detail, I believe, about tank availability. Let's talk about a CNG pressure regulator. From the CNG tank, you have a stainless steel line that goes under the vehicle to the regulator. Now on the regulator, you're going to have the pressure sensor, lock-off valve, coolant inlet and outports, because this is heated by the antifreeze so that it doesn't freeze up. You have the high pressure CNG inlet port coming from the tank. You have the reduced pressure because this is dropping it down from 3,600 PSI down to, depending upon the system, around 65 or 70 PSI pressure. Much like the regulator on your gas grill at home, it works very much in the same way. Now, from there, a low pressure hose goes to the injector rail. The injector rail is going to have a coil, CNG inlet. This is where the low pressure comes in. You have your air plenum nozzles that actually end up going directly into the intake manifold, and the injector nozzles. So this mounts on one part of your car, and then you have a high pressure lines and hose that are actually low pressure lines that go to each of these. This is for a 4-cylinder. You'd have 6-cylinder. You'd have 8 for a V8. You're going to have stainless steel line. You're going to have stainless steel compression fittings. You're going to have a pressure gauge. You're going to have an NGV nozzle. This is where you connect the fueling station to fill the vehicle, and this can be located pretty much anywhere on the vehicle. I've seen them in every possible location you can think of. You're going to have all your fittings and connectors. You're going to have the ECU and cables. This ECU ties directly into the car's computer. They talk together. Now, when you have the wiring harness then, you're going to have the TPS input, the EGT sensor connector, an RPM input connector, the boost sensor harness, the fuel level interface, tied into the brake cruise control wiring, tied into the key on power ignition, and tied onto the fuel gauge and system. So on most sequential injection systems, you'll be tying into the different parts of the vehicle. A low pressure hose, fuel gauge which mounts inside the vehicle, and from this fuel gauge you can tap it to turn it on, you can tap it to turn it off. You have a lock-off solenoid, so when you turn the vehicle off, or if you have sometimes it's tied into the front bumper, so if there's an accident, this electronic shutoff will automatically shut off all CNG flow to the regulator. Now, on a typical vehicle, you're going to have to tap into the intake manifold, and in this example, a hole was drilled, and then each intake manifold was ducted. We highly recommend you actually pull the intake manifold off to do this. I have seen guys hook a shop vac up to the intake manifold and drill them. I prefer actually pulling the intake manifold off and doing it right. This is a close-up of the intake manifold, and then now you put it all together. So this is a V8. You're going to have 4 injector rail here, a 4 injector rail on that side. The ECU, you're going to have filters often, and some companies use them, some don't. You're going to have a pressure sensor, and then your regulator. So you tie it all together into a functioning CNG system. Now, if you do a turbocharged gas vehicle, you're going to run into some issues. One, you cannot drill the intake manifold, and you must collect the sequential injectors. And there's when you do a turbo, you do have pre-turbo mounting concerns. There are post-turbo benefits, and we actually ended up using a fumigation system tied in the sequential system, which was something we actually invented and designed, an advanced timing crankshaft and anti-knock. Now, something you have to be aware of. Okay, CNG is very high octane. It's 130 octane. So to take advantage of that, the vehicle somehow needs to advance the timing. Like on our vehicle, we advanced it to 10 degrees before top dead center to take advantage of the high octane. If you don't have some way of advancing the timing, that's where you hear the stories about reduced horsepower, reduced fuel economy, because you're not taking advantage of it. This particular car my car, what we did is we took the sequential injection system, and if you look real close, you can see the bolts where we actually put bolts back into the intake manifold. We originally tried it that way, but what we believe was happening, because this is turbocharged, that the methane gas was transferring back and forth between the intake ports. We were getting white spark plugs one time, dark brown spark plugs. We couldn't figure it out. So there must have been some kind of a vapor lock going on in that in the turbocharged intake manifold. So what we did is we brought it all together. We tapped into the intake line, the air intake after the intercooler, right before the intake manifold, and we actually built a direct injection fumigation. So we fumigate the fuel at this point. It mixes in the intake, and it worked perfect. Whether we were at 120 miles an hour or at 10 miles an hour, we had balanced color on all the spark plugs all the time. This is a close-up of what we did using a fumigation. Now this is also heated by antifreeze. So it's a double-walled fumigator. It's warmed, it's hot, and then we tapped in each line. So there's four, it's a 4-cylinder engine, 4 sequential injectors running into a fumigator. The next thing is called an upgrade kit. There's very little information available about this right now, but I'm just bringing it to your attention. Supposedly, this is not considered a conversion, and therefore is not under EPA scrutiny. A representative at the EPA was quoted as saying, "This is not a conversion kit as defined by the EPA, but rather no different than installing aftermarket spark plugs." Now, what's the difference? How does this one work? If you look at a normal CNG system, the stock ECU is talking back and forth to the ECU emulator. You remove the sensors, you're putting in aftermarket sensors, you have your LP or LPG injectors, and then this is the factory fuel injection rail. Well, in this system, it's only one-way communication from one-way ODB transmission. You're using the stock sensors. The stock fuel injectors are still in place, and the ECU talks directly to the injector rail. By not replacing the stock sensors or trying to send false information to the stock ECU, the Edge Fuel system is able to maintain all of the OEM safety, diagnostics, and emission controls. Converted vehicles can be serviced by technicians with standard equipment without the worry of additional steps to diagnose system errors because of false readings. So this is something new that's coming on the market. I wish I could say pro or con about it. We're going to have more information, and we'll be posting in the next couple of weeks information on our website about it and have some updates for you as we find out more. Here's a video that's not working, but this is so cool. This is a 500 horsepower Volkswagen Bug running on natural gas with twin turbos. You had to go to ceramic pistons because of the high heat output. It has double CNG mini tanks in the back, and you can't drive this thing without spinning the tires. I had a chance to get in it. It is the coolest thing you ever got. It's a Porsche eater. It's insane. It was so much fun. But just to give you an idea, he wanted to prove, he put in high compression ceramic pistons, he wanted to prove that CNG very viable racing fuel. This is also the same gentleman, him and his brother were from Team BMW. They're the ones that set up my car for the World Race 2011. So now we're going to jump in and talk to you about diesel CNG. With diesel, you can do either what's called a dedicated conversion or a CNG booster system. Now on a dedicated conversion, you have to put in lower compression pistons. You have to change the valve timing and redo the heads. You add spark plugs to where you used to have diesel injectors. You add an ignition system. You have to put in a bigger radiator, water-cooled turbo, and then it becomes dedicated CNG only. I don't know if you're aware of it, but LP is about 105 octane. CNG is 130 octane. That's why CNG works so incredible in a diesel stroke engine. Now, or you can do there are a lot of fleets across the country. I think Quick Trip's even doing some dedicated CNG engines, right? Yep. But what do you do in the meantime? What do you do in this bridge period? You have millions of dollars of existing diesel pickup trucks in your fleet. They're in pretty good shape yet, but what can you do? You can do a CNG booster system which uses between 20 and 30% CNG. So you have a CNG tank in the back, you're always running on diesel fuel all the time, and as you drive down the road, whether it's a vacuum system or a sequential electronic system, you're varying the amount of CNG that goes into the engine. On normal pickup trucks, guys are using about a 30% boost. They're almost doubling their fuel mileage on a diesel pickup truck. Immediately, you're going to get 100 to 150 foot-pounds more of torque out of that engine. But you got to be careful. You can't run too much CNG. If you're running too much CNG, you actually can melt down a stock diesel engine and melt the turbo right off the motor. So you really have to know what you're doing, dealing with an experienced shop in doing it. There's sequential systems, which means it's fully electronic. And then there's fumigation systems that are also just work off the vacuum. We're going to be covering those. But with any of these, there's very little, if any, modifications required to your existing diesel engine. This is pretty much an add-on, bolt-on system. Now this example, technology gets tricky, so bear with me. This example I'm going to give you next is an aspirated vacuum fumigation. This is called the poor man's CNG conversion. There's no electronic metering. It's strictly vacuum controlled. It's usually a fixed delivery rate of 10 to 30%, which means when you're going down the highway at 60 miles an hour, wherever that valve is dialed in, that's it. It's fixed. There's problems of over-fueling, though, on deacceleration because you're vacuum operated. Deaccelerating, you're over-fueling, and then accelerating, you're under-fueling. So you get that turbo lag a lot, but and there are no safety shutoffs on a typical vacuum system. There's backfire issues, but it's the very, very cheapest cost. You can convert a diesel engine very, very cheaply, and these systems are out there. Brazil's got a bunch of them, but I really don't feel they meet the American need for safety, especially on any vehicle that we have insurance on. Now, a brief description of aspirated. I'm going to read this quickly. The two main components in an aspirated CNG system are the pressure regulator and the mixer. The addition of a controller system, which includes an ECU and a stepper motor to regulate natural gas flow, was added when closed-loop fuel injection engines came out in the 80s. The basic system with the regulator and the mixer still remains the most popular and most used system worldwide. An aspirated system, again, what does aspirated mean? It just means it's using vacuum running through the air without electronics. An aspirated CNG system starts with the high pressure CNG. The tank is connected to the filler. Pressure regulator with high pressure steel tubing. There may be a valve or high pressure filter between the tank and regulator. On carbureted vehicles, the in-cab controller switch will be the control for the system with a three-way switch and manometer, electronic pressure gauge. This switch, when operated, will turn off the gasoline through the use of an electronic shutoff in the fuel. As the gasoline runs out, you switch to natural gas, which is introduced through a mixer plate above or below the carburetor, much like the older LP systems. The natural gas is then regulated by manifold vacuum by the regulator. Now on fuel-injected vehicles, the simple mixer system is the same with the addition of injector emulators. These are spliced in and are plugged into the vehicle injector wires and turn off the injectors when the CNG system is turned on. A closed-loop controller is an addition to an aspirated system, which uses the oxygen sensor along with the throttle position sensor and an RPM signal to operate a stepper motor, which is nothing more than an electronic valve, to control the amount of natural gas introduced into the system. Now, I don't expect any of you to walk out of here and be able to install a CNG system. I just want to make awareness of all the different components that are involved in CNG. Now, how does it work? Once the system is installed and working, no CNG is used when the engine is idling. A hose is connected from the regulator to the air intake between the air cleaner and the turbo. When engine load increases, the turbo creates an increasing vacuum in the air intake before talking about a diesel truck that has a turbo. As the engine load continues to increase, the vacuum continues to increase, causing the regulator to supply more and more CNG. There is a flow control valve in the fuel vapor line controls overall fuel curve. A simple dash-mounted switch turns the unit on and off, and it also turns on and off with the ignition switch. Now, if you're running propane or CNG, I'm going to skip that. It goes into the talking about LP a little bit too much there. Now we're going to get into the specifics so you understand what we just talked about. This is a Ventura mixer or a fumigator. This mounts on the intake line of the vehicle, right on the air intake. You have the vacuum CNG regulator. In this example, they mounted it actually in the bed of the truck. The problem with mounting it in the back of the truck is you have to run a CNG line, a soft hose actually, down under the vehicle up to the engine. I personally have a safety concern with that. They do it in the truck bed because they say it's cheaper. But you also then have to run double lines to the heater core and back so you can heat the regulator. So, you know, it's, what is it? Which way is really better? I prefer the regulator up in the engine compartment with a heavy-duty stainless steel line going from the tank up into the engine compartment. This is an example of a vacuum-operated regulator. Well, no matter what kind of CNG conversion you do, you're going to have a standard regulator. But in this situation, they're adding a vacuum-operated module, which is controlled by the vacuum of the engine. That is what increases or decreases. Now, we're talking about an aspirated, the terminology in this system is aspirated system for diesel. In this case, all he did is made a simple venturi out of copper piping and tapped it into the intake manifold. This is an exploded look at that. Simply tapping into the intake, creating a venturi to supply the natural gas to the vehicle. Here's an exploded look of the hose coming into the intake. And you can see the two red lines. Those are the two red lines going to the regulator to heat the regulator. This is an interesting position, interesting place to put a regulator, but I guess a lot of times you have placement issues on a vehicle. I don't know in Wisconsin that I would want my regulator down where all the salt and snow gets splashed on it. And this is a tank, a pickup truck mounting the regulator back in the bed of the truck right next to the tanks. Here they're hooking up the electronics, and on a semi-truck, this is actually going around to the mining fields in the United States. This is fairly common in the mining areas. You'll see a big stack of CNG tanks. In this case, these are the Type 1 tanks, which are the cheapest tanks, but they're very heavy. So they're stacked up here. And they also have a big CNG tank on the side of the vehicle. A lot of these conversions were done in the early days when you just couldn't go out and buy conversion kits for certain vehicles. So very creative men came up and did their own things. Now, did you know, according to the Northeast Sustainable Energy Association, back in 1860, I can't even pronounce that name, somebody of France, developed and built an engine of a design practical for natural gas, CNG, that ran on illuminating coal gas stored in a rubber bladder. Now, if you can picture a bratwurst skin 1,000 times bigger, okay, that's where you stored the methane. And the primary component of the natural gas and hydrogen. In 1862, they built a vehicle powered by one of his engines. So this means the first internal combustion engine was powered by CNG. The very first one. Something I didn't know. Now CNG again has an octane of 130 while propane is 104. The higher the octane, the more heat and pressure it needs to explode. This means there's less danger with CNG pre-igniting in a diesel than there is with LP. Now, what about the next stage? We just talked about the aspirated system on a diesel. The next type of system is a diesel booster system. It's electronic fumigation, very similar to the electronic sequential injection system. Now, a compressed natural gas system, CNG, works similar to nitrous oxide or propane. Basically, it's adding for more to the diesel fuel, but doing so by spraying it into the intake plenum. Now, according to Diesel Power magazine, owner Jeff Dean hit 38 miles to the gallon on his 1999 Dodge Ram 2500, 24 valve. He had a 5-speed, he did a bunch of other modifications, but he was the winner of last year's mile per gallon challenge with Diesel Powered magazine using CNG boosting. So if any of you have those Dodge Ram diesel pickups, 38 miles to the gallon just isn't too bad, is it? Plus, I don't think it says here, oh yeah, 1,170 foot-pounds of torque. Now, here we're getting into what I call the more modern, the more readily available, the more recommended CNG conversions. These are the electronically monitored and controlled CNG systems. This is a Type 4 carbon fiber tank, extremely safe. When you get into the CNG diesel booster systems now, the electronic ones, these are the components that are going to be in the kit. You're going to have an EGT sensor, you're going to have an RPM signal interface, a boost pressure sensor, an RPM, a diesel booster regulator, a CNG controller, and then you'll have to find a place to strategically mount the tanks on your equipment or trucks. Now, on these electronic systems, you're going to have a boost pressure sensor always monitoring the fuel flow. You're going to have your fuel nozzle coming in, and you're going to have a pressure compensation port. So your whole system is always being monitored to make sure that everything is running at optimal performance, and you're also measuring exhaust temperatures. So exhaust temperatures get too high, it backs off on the CNG. Again, very important. You don't want turbos melting off your engine. Now, you're then also going to have the pressure regulator. On your pressure regulator, it's mounted on the side of the engine. You have the CNG gas outlet. You have your pressure compensation port connected, the CNG gas inlet connected, the lock-off fuel level and temperature sending wire, and the coolant lines coming in to heat the CNG system. I apologize if this is too much detail, but we wanted to really give you an idea of how much work it goes into converting a vehicle and what is involved in it. Now, again, our video's not working. We'll skip that. Advantages of an aspirated system versus a sequential injection. Well, if the aspirated systems are affordable, they're about $400 to $525 without a tank. They're very easy to install. There's less components. It can be used on a carbureted vehicle. Tuning and setup is simpler. What the disadvantages are, you have a power loss and you have less fuel regulation. Very little control over the fuel going in and out, and it's old technology. It works best on the old vehicles or old equipment. Advantages of sequential, you have more control on your CNG operation, fewer check engine lights. The other systems, you will throw check engine lights. You have less power loss. It works good on the newer vehicles, and the modern system using multiple sensors to regulate the natural gas. Everything's communicating, everything's talking. Your engine always runs at its peak performance. Now, what are the disadvantages? It's more expensive. A CNG kit, just the kit, is about $2,000 or more without the tank. They're harder to install. You need to remove the intake manifold in many cases. They're harder to tune, and you will need tuning software and a technician that can hook his laptop up to it and dial the car in. Now, here we get into the controversial part, Bob. EPA versus non-EPA kits. We could have an all-day debate on this, but we're going to do it in about 4 minutes. EPA conversion kits are often installed by factory-trained technicians trained on servicing and installing the manufacturing kits. Now, EPA certifies kits as follows: the current model year and the prior year. It cost a kit manufacturer about $250,000 per engine per model year to get a kit approved by the EPA. Then, because of the new rules just from last year, they loosened up a little bit. They said, well, okay, if your vehicle is 3 years old or more, we're only going to charge you $50,000 to get your CNG kit EPA approved. Or you can just, if your vehicle is outside of the service life, which is about 120,000 miles on a gas vehicle, about 435,000 miles on a heavy-duty semi-truck, you only have to do a paper certification to get your kit certified. So this may still sound very strict, but it's a huge loosening up from the EPA from where it used to be. Now, why the EPA? Back in 1994, Congress empowered the EPA based on actually a false study that was done that LP vehicles, if the kit wasn't properly installed, could actually increase pollution. Now, I dare anybody to challenge that statement. If the vehicle is running good, how could LP or CNG actually increase pollution? That vehicle would have to be knocking and bucking and running so poorly, and it still would probably pass smog control. CNG fell under the LP Conversion Act. Primarily, the main reason for the EPA is to make sure the kits are safe and that they're tested, and that they also, when installed by original manufacturers like General Motors and Ford and Dodge and Honda, that they must be warranted for the emissions life of that vehicle. Now, CNG freedom of choice. Do we really have a choice when it comes to CNG conversions? There are those who say our choices are very limited. I personally say we live in the land of the free, and we do have freedom to choose. Some try to limit our choices by using general statements such as, all CNG conversions must be EPA certified. If not, are they illegal? CNG conversions that have been EPA certified are always clean and safe throughout the life of the vehicle. Non-EPA certified CNG conversion kits are unsafe and run dirty. That's what opponents to the aftermarket kits say. These broad statements only divide people. We need to find some common ground. One thing that everyone who is involved in the CNG industry can agree on is that CNG conversions should be clean and safe. We all agree on that. The disagreement comes in when those in the CNG industry try to decide how this is to be accomplished. Now, there are about two schools of thought have developed. Let's call the first group EPA hardliners. They believe that only a select group, EPA certified system installers, are actually capable of producing clean and safe and legal CNG conversions. Let's call the second group independent converters. They believe that clean and safe CNG conversions can and should be available to everyone. Do you realize that of all the vehicles produced, of all the cars, all the trucks produced in the last 6 years, 98% of them do not qualify by the EPA to be converted. They're illegal to convert according to the EPA. 98% of all vehicles. That means that there's only 2% of the vehicles on the road have EPA approved kits available to them. So that's what people like me and others in the industry, we believe that as long as you have a certified installer, certified installers that are trained to inspect, test, and service the CNG kit should be allowed to install aftermarket kits. Now, I'm not going to go through these in detail, but just to highlight them, can I convert my car to CNG? The EPA hardliners are going to say, yeah, if you use an EPA kit and you're willing to pay $10,000 to $30,000 for that conversion. The aftermarket people are going, yeah, you should be able to do it. In fact, some of the most sophisticated tunable systems are installed by independent contractors and converters. Well, convert my car to CNG. The hardliners are going to say only factory-trained people that install EPA-approved kits. The aftermarket people, let's run our people through a CSA-certified program. Let's get them trained and open it up to a lot of people in the country being allowed to do conversions. Can I get a tax rebate for my conversion kit? Well, you can pay a lot more money for an EPA-approved kit and then get the tax credit back. Or you can pay a lot less money up front for a CNG aftermarket kit, but you don't get any rebates. No rebates are available for aftermarket kits. Will my conversion continue to run safe and clean throughout the life of my vehicle? The EPA certified people are saying, well, yeah, conversion is only tested and it's tuned throughout the useful life of the vehicle. And it's usually 100 to 120,000 miles. If your system starts running out of tune, you will have to return to the factory installers for tuning and inspection since the tuning system is sealed. It's sealed. You can't adjust it. On the aftermarket kits, they're completely tunable and adjustable. The factory kits, you can't get in and change any of the operating parameters. The aftermarket kits, you can. Is there such a thing as an illegal CNG conversion? The EPA guys say yes, all CNG conversions are illegal unless they are EPA certified. Again, they're saying 98% of all the vehicles in the world are illegal to convert because there's no EPA-approved kit available for them. The aftermarket people are saying no, all CNG conversions are legal. The EPA has stated that components are not to be tampered with. This tampering includes removing or rendering inoperative emission components. To the best of our knowledge, the EPA has never prosecuted or fined an individual for an aftermarket installation. Now we're in the controversial stuff, as you would call it. Bob does not claim to represent or agree with anything that's about to be said.
Couldn't have said it better.
Thank you, you're welcome. Are there any nationally recognized governing organizations that oversee all CNG conversions to guarantee they are clean and safe? Yes and no. The EPA is mandated to offer a certification process for the CNG converters. The aftermarket people are saying no. There are many national training organizations that have programs on CNG installation and safety. Each independent CNG installer is responsible to test their installation through independent safety emissions and testing. This is accomplished using local CSA, CNG system inspectors, and by meeting a vehicle's state emission standards. Right here in Wisconsin, we have a lot of small family-owned gas stations in the Milwaukee area, et cetera, that are certified by the state of Wisconsin to do independent vehicle inspections and emissions. I'm proposing we go that route, following the lead of Utah, following the lead of Texas and Oklahoma. Now, some individuals may choose to install EPA certified conversion systems. These systems do have the added advantage of rebates and tax credits. They may also satisfy the Clean Air Act amendments of 1990 and Energy Policy Act of 1992, while promoting lower emissions and alternative fuel strategies. Those who choose independent converters have more flexibility. Modern CNG conversion systems are available for virtually every make, model, and car and diesel engine. These conversions may be done on an individual basis in smaller shops all over the United States. There is now training available for individual mechanics to become competent in installing and testing vehicles. I envision the CNG install and repair facilities, both EPA and certified independent converters, all over the United States. That is actually my vision. I see CNG shops helping each other through information sharing, parts distribution, training, and certification. The EPA hardliners need the added revenue of aftermarket CNG conversions. The aftermarket conversion shops need parts and tuning information. As the EPA certified systems begin to break down, conversion should not be viewed as illegal or legal, in my opinion. Now, vehicles to convert. You're here, you're thinking about what should I buy? What kind of vehicle should I convert? Well, the good news is in 2013, Chevy, Ford, and Dodge are all coming out with pickups and vans that some of them are even going to be bi-fuel. I'm a big believer in bi-fuel because what happens when you run out of CNG and you're in the middle of nowhere? I understand Quick Trip has the answer to that. They're going to have 24/7 emergency, I'll fill your tank with CNG service if you're part of their group somehow. It's my rough understanding. Jump in.
Sure, okay. Yes, what we're looking at doing basically is being able to offer roadside assistance under the aspect of conversions. Part of our fleet solutions is to utilize our fleet facility to do conversions for the masses along with our own fleet. Long term, that's not what we want to do, but we see that being the best avenue to get vehicles to the market.
Okay. So that's one option. The other option are bi-fuel vehicles, and here are some. Ford's going to offer Ford offers the 6.1 liter engine. Now, why is that so cool? Because that engine comes from the factory already pre-tapped to accept a CNG conversion system. To my knowledge, it is the only engine on the market that is mass-produced, already able and willing to accept CNG. It has the flex fuel vehicles are also set up, surprisingly, to be easily adaptable to convert to CNG. The 2013 Dodge and GM, and actually most engines since 1995, most vehicles already have the better valve seats and valve guides, but for sure the ones up above. Now, what does a better engine design mean? It means you have hardened intake guides on the valves and that you have hardened valve seats on the exhaust. That's very, very important because CNG is so dry. You can also, from Ford, get the gaseous fuel package. So if you order a Ford and you're going to do your own conversion, make sure you get the 6.1 liter engine and you ask for the gaseous fuel package. They don't charge anything extra for that. Engine oil. A lot of times this is really overlooked in the CNG conversions. Running regular base petroleum oils, you can actually destroy. I've heard horror stories. Well, I got 70,000 miles, I got 80,000 miles on my conversion, and my engine went to heck. I've got friends, Amish friends up in Canada that run a lot of the B6 Cummins generators. And they actually destroyed several generators by using petroleum-based motor oil. The only two that I'm aware of, and if anybody else knows of any others, jump in, but the only two I'm aware of is AMSOIL actually makes a natural gas synthetic oil, and Chevron just came out with a natural gas, a synthetic blend motor oil. Now, what's the key ingredient? Phosphorus and zinc. You're going to need more phosphorus and zinc because you're running in such a dry fuel, and that's what makes a huge difference. So those oils I'm aware of are already designed for natural gas. Just to sum it up, I'm with CNG Pump. We make the home fueling stations for natural gas vehicles. This is the home unit. We also have a larger one for trucks and pickups. And we are the world's only manufacturer of the hydraulic compressor. It's smaller, the thing lasts forever. This is one actually running out in California. And then this is a very large 60 gallons per hour GGE compressor using hydraulics instead of a reciprocating compressor design. Engines can actually last longer. You can extend maintenance. CNG is virtually 90% pollution free. If tuned right, you can actually get increased horsepower, especially in a diesel. 100 to 150 foot-pounds more of torque is very common. And it's a lot better than electric because I've never seen electric yet work in commercial vehicles. So I'd like to thank all of you for coming, listening to a very technical presentation. 99% of you stuck with me. I really appreciate it. And I'm sorry I couldn't show highlights of the world race to break this up. But the way the race ended, the Corvette won the race of the 2011. I almost broke the national record for the longest distance on travel on natural gas. Only about a third of the 6,800 miles, I did have to run that darn gasoline, but I have something more in common with Bob than I originally thought. Coming back across Nebraska, 2 o'clock in the morning, 80 miles an hour, I hit a deer with that Volkswagen Jetta. Took out the front left corner of it, and thank goodness none of us got hurt. But I'm available if anybody has questions, would like to get a hold of me down the road. Absolutely glad to talk to you. Thanks again, and have a great day, and hope to see you at the next meeting.